let's continue from where we stopped. So, okay, next let's go to value counts. Okay, so basically it counts number of rows with each unique value of a variable. Okay, so suppose it counts the unique, like if we have an origin, right? So column origin, it has Japan. We already checked, right? Using filters, it has Japan, Europe, Japan, and US. So let's try this value counts to this column and see how we get the result. Origin dot, this is how we call the value underscore counts function. It's cars. See, it says the US has 245 rows. US gets 245 times. Japan gets 79 times. Europe 68 times. So that's how we interpret this. Suppose we check the cylinders also. Let's check cylinders. Counting the cylinders. Unique values. Unique values of cylinders column. Okay, see it says 4 occurs 199 times, 4 cylinders, 8 occurs 103 times, 6 occurs 83 times, 3 occurs 4 times, and 5 3 times. You can check with the year also, how many times each year has occurred. See 73, most number of models were there in 73, then 78, 36 models, like that you can interpret. Okay, so okay, next length. So what does length do? Actually returns number of rows. Returns number of rows. Length and cars. This is the function how we call. So it, how many rows are there? 392 rows. Okay. Next sum. What is sum? Actually it counts. I mean it sums up. Suppose let's call an MPG column and check the sum. Basically, it adds the each row in MPG column and gives the number. Okay, so we have MPG, right? So this MPG, all the rows in MPG column are added, and that final number is given. So we have count also. Count. Let's see count. What does count do? So again, count also gives the number of rows, like non-null values. So if you see there are no there are no null values, so it directly gives the number 392. And you have function minimum. It gives the minimum number. Cars. Suppose you want to check the minimum number in horsepower column. Dot min. So it's 46 minimum number. We have max also, like that same. Cars. Suppose you want to check what is max in acceleration. Dot max. So the max in acceleration is 24.8. And we can do some statistical operations such as mean. Want to check what is the mean of MPG dot mean. Sorry, it is cars. So it's 23.44 is a mean miles per gallon column. The MPG column has mean of 23.44. Then we can check the median also. Okay, so 22.75 is the median. And then what is the standard deviation? That also we can check. STD, we have a function called STD cars mpg.std. So 7 point is standard deviation, 22.75 is the median, and then 23.44 is the mean. Okay. Okay. So here we have defined initially I've defined some numerical and categorical variable, right? So let's again uh, define in detail what is a categorical variable and what is a numerical variable. Okay. So what is a categorical variable? Any variable that is not quantitative. Simple. Quantitative in simple terms, which is not quantitative is categorical. Takes a value that is one of the several possible categories. That is one of the several categories. Suppose we have different countries right here, so it takes one of this row takes US. So we have three different countries: US, Japan, and Europe. So this value takes US. Out of three categories, it takes US. Okay. So that is how we define. And sometimes categorical variables can have numeric can be numerical, sir, can be numerical also, but that does not have any numerical sense. This point should be noted. Why I'm defining this is, suppose like we have cylinders, right? So cylinders, it's a numeric. It has 8 go to value counts 10. Okay, the here see, here you have different 4, 8, 6, 3, 5 are different cylinders. This looks like numerical variable, but this doesn't have any numerical sense. This is a categorical variable. This can be divided into different categories such as 4, 8, 6, 3, 5. So please make this point clear. This point is very important. So though it looks like a numerical variable, it is not a numerical variable, but it is a categorical variable, because for numerical variable or mean, median, STD all works. Suppose if you take mean, median and standard deviation, does it make any sense for this column cylinders? No, right? So please make this point very clear. Examples of categorical variable: gender, countries. So gender, male, female, countries, US, UK, Japan, like that. Okay, next let me define what is a numerical variable. Numerical or quantitative or continuous. All these are same, one and the same. So variables that are measured on numerical scale. Numerical scale. Suppose the example age, income, variable age variable changes from one point to another continuously, right? There's age, income, same way income also changes from one point to another, varies from one person to another continuously. Okay, so let's once check, go back and check info. See this model live model MPG is a numerical variable. Cylinder size, as I said, it's a categorical. Displacement numerical. Horsepower numerical. Weight also numerical. Sense acceleration numerical. Year categorical. Origin categorical. So that's how you define numerical and categorical. And also cars dot describe. Once check describe also. See, MPG, all this will make sense. Cylinders, it doesn't make sense because all this 5.4. Why 5.4 makes sense if mean of all cylinders? Why? Because it can be categorized into different categories and that doesn't have numerical sense. So for cylinders, this doesn't make any sense. The mean, standard deviation, minimum, and all doesn't make any sense. For displacement, yes, it's because it's a numerical variable. For horsepower, yes. For weight, yes. Acceleration, yes. And also year, why does it make sense if you take a mean, standard deviation, minimum, and all? It doesn't make sense. Okay, so we should make this point very clear. Okay. Now let's explore some categorical variables from our data set. So what are categorical variables we defined? We defined cylinders as categorical, we defined year, we defined origin, right? So let's explore origin, cars underscore origin. So how do we explore? We explore using unique function. We have a function called unique. You see, it gives all the unique values. It separates all the unique values and gives the unique the array. Okay. So see, if you check info, we have defined cylinders as categorical variable, right? But it is taken as int because since it is of numerical, since it is a numeric, it is taken as int directly. Default by default, it is taken as int. Same way, origin it is taken as object, but for our as per our understanding, its origin should be in a categorical variable. Cylinder should be a categorical variable. At the same time, year also should be a categorical variable. So once we import the data, we have to convert these like this data types into their respective meaning, like sensible, logical, convert into such a way that that should have some logic. Okay. So let's convert these variables into categorical. First, we have to let's convert origin into categorical variable. So how do we convert first cars origin? Cars origin. See, this is how we convert as type, give it as category, small numbers, small letters. Okay, this is how we convert. So this column is an object. Here it is an object. I'm converting this into category because this is a categorical variable. Okay. Now let's check this. Now see, see the difference between this and this output before we convert into uh, a categorical variable. See the difference. So it says clearly three categories: US, Japan, Europe. Okay, so you have to convert that whatever variables required into categorical. So let's convert this cylinders into categorical variable. So before converting, let's check the unique cylinders. Okay, see, arrays is created and the data type is int. So let's convert it into a. I'm converting the cylinders into category. Now let's check the unique. See, it says five categories of int. The 8, 4, 6, 3, 5. Those are integers, and it is divided into factorial. Here, three categories. Those are objects. Those are divided into the categories are US, Japan, Europe. Same way, you can convert that into convert this year column. How many others? Some around 10 to 12 years are there. So you can convert that into categorical variable. So So basically, why it is important to explore categorical variable? It's very important to convert into categorical variable and explore, because categorical variable plays an important role. Will be handy at the time of group by operations. Will be very handy. You remember very handy. I'll tell you what actually group by is in the next coming minutes. So it's a categorical variable, always important to explore, and it plays an important role in group by operations. So what are group by operations? We'll discuss now. Okay, so let's go to the group by. Okay, so group by. So this is a syntax for group by. Data frame dot group by, and you have to give the column name here. Put the column name. This is the syntax. Actually, what it returns a group by object grouped by values in column name mentioned. So see, this is the data frame dot group by, and you are giving a column name. This column name, always remember, if it is a categorical variable, it's very easy to group by, because it can, since categorical variable has categories. Suppose this origin we have US, Japan and Europe, right? Suppose I am doing group by to this cars data frame, and I'm grouping by US origin column. So it groups by each category in the origin. It groups by US, it groups by Europe, and it groups by Japan, and puts every category variable, every category rows at one position. Understood? So this is how group by works. And also, group by should always be followed by some operation. Some that operation can be any operation, that can be minimum, mean, maximum, any operation. So let's perform some operation, then you will understand. Suppose I am doing group by to the cars using the function origin. So what it does, for till this point, what it does, it groups by each category in the origin and puts all each category rows in at one point. and it puts like this, and then we have to put do some some aggregate operation after that. Suppose if we call the minimum function, so what it does is each in each category, origin has different categories. Each category, what is the minimum value? It pulls out all the minimum values from each category of all the rows from each row. Just run this, you will understand the output. See, so first it divides into each category. All the rows of each category are displayed, and then I'm calling the minimum. So all the rows, from all the rows, the minimum value of rows, minimum value of that all the rows will be extracted from each category. From each category, remember we are grouping by category called origin. Okay, so I forget this model column. So for MPG, Europe has 16.2. The minimum value of Europe is 16.2, displacement 68, horse per 46. Like that, you have to interpret this one. Okay, getting the minimum value of, yeah, I'll write down just to make you easy. Getting the minimum of each column, group by origin. Hope you understood. Okay, so what I'm doing is first I'm dividing the data sets into categories as per the categories I'm putting. So first Europe, all the rows I'm putting at one position, and then Japan at one position and US at one position. I'm taking the minimum from each category. Okay, let's check mean now. So this group by is very handy, very important at the time of exploratory data analysis. So please focus. So what it does is for each category the mean is calculated for all the numerical variables. Ignore this here, we did not convert this into categorical variables, so that's why it is coming. So for MPG, the mean of Europe is 27, the mean of Japan is 30, and the mean of US is 20. That's how we interpret. Okay. Now see, the cars has different category, the different numerical variables. For all the numerical variables it calculates the means, but I'm very particular about only few columns. Then what should I do? I want to have only few columns, not all columns. Then you have to execute this function group by only limited. Okay, so cars, same, copy this. So I'm grouping by origin, but only I want few columns. Then you have to give double square brackets and then give the column names. I want MPG and weight. Suppose I'm taking the mean here. Suppose I'm aggregating using mean function. Okay, so see, origin Europe, what is the mean of MPG and what is the mean of weight for Europe? For Japan, same, mean of MPG, mean of weight. For US, mean of MPG, mean of weight. That's how it is displayed, right? Okay. And also, not only just for one variable, we can do multi-level grouping. Say, like we can use multiple variables in this group by column. So let's do that also, multi-level group by. Not only we do multiple group by, we can also do multiple aggregate functions. Like this part, we can do mean, standard deviation at the same point. So let's do that. Multiple aggregate functions. Okay, suppose you take this. So I wanted to perform multiple aggregate functions. So this is the syntax agg.agg, open the brackets, give multiple. So for always multiple, it should be enclosed by square brackets. Okay. Multiple. I am giving suppose minimum and max. Suppose I am giving minimum and max. Okay, so what I'm doing is grouping by origin, and I'm selecting only MPG and weight, and I'm aggregating using minimum and maximum. This okay. Origin Europe, the minimum is for MPG minimum is 16.2, for maximum MPG is 44. Japan 1846. That's how it. See, it looks very interpretable, very easy to interpret, right? So that's how group by enables us to make it very interactive and interpretable. And also we can do multiple, not only just multiple group by, multiple aggregations and multiple group by at the same time. Multiple aggregation. Okay, so once you select this, what I'm doing is I'm giving cylinders also, and I enclose it using a square bracket. Okay, enclosed, and I'm selecting only MPG and cylinder. I'm giving mean and standard deviation. So how it looks? 1 second. Okay, so the problem here is I did not give cylinders. So as see here, I got it. So be careful in giving the column names. Okay, so for each origin, the categories in the origin, and also categories in each like categories in cylinders. Europe 4. What is the mean MPG 28? What is the standard deviation 6.2? Weight. What is weight in Europe 4 cylinders? What is the mean 2338? Like that, it's very easy to interpret and it's very interactive. Okay. So group bys are very handy at the time of manipulations. So you can interpret very useful points. Now let's go to the next concept called merge. So for merging, we have to define a data frame. So let me define a data frame first. World population. I'm defining a variable named world population, that pd.data frame. This is how we convert, right? Data frame, pd.data frame, open brackets, open. So here I'm defining a dictionary inside. That dictionary I'm converting into a data frame. So how do we define dictionary? We have already, I told you, right? So first you define the column, first column and values. Country, suppose I'm defining the country, and what are the values here? Suppose I'm giving US, China, Japan, India. So I'm defining the country variable, yes, so column name, and I'm giving the values as US, China, Japan, and India. And also I'm defining a another column population. I'm giving the values. What is population for US? Around 32 crores. China, it's around 142 crores. Japan, it's around 12 crores, and India, it's around 130 crores. So these are only rough figures. Don't worry about the figures. So first, what I did is I defined a dictionary inside, and I'm passing it to data frame. So it converts directly into data frame. So let's display the result. Okay, so see, I'm creating a country column, population. I'm converting that into a data frame. So we have four columns, one, two, three, four columns and two. Sorry, four rows and two columns. Again, see, this is for first data set and another data set defined the same way. Another data set. I'm defining another data set called GDP. GDP. So countries remain. Suppose countries are the same, and I'm defining GDP. So what is the GDP of US? It's around 18 trillion, right? So what is China? It is around 11 trillion dollars. Japan it is around 5 trillion. India it is around 2.2. Let's take it as 2. So GDP. Okay, so see, I'm defining two data frames: one country and population, and another GDP. So okay. Now I want to merge these two data frames. How do we merge? We have a function called merge. So world, I'm creating a name world underscore pop underscore GDP is equal to, we have function name in pandas merge merge, give these two names left right comma right, these two names, and then we have to give another constraint called on. So on you are giving what is the common between these two uh, data frames? It's country, right? So based on country we are merging, taking country as a common column, and we are merging on this. So let's check the result here. So what is the result here? See, country is common, right? So it gets displayed only once. Population and GDP. See, GDP gets merged to this population using this country as a constraint on. Okay. Suppose one country data is not present in one of the data frames. Suppose this scenario we're handling now. Suppose in GDP, let's say that India's data is not there. Suppose example in GDP India's data is not there. So let's delete this. So only we have US, China, Japan. It's 18, 11, 5. Yeah, only three columns. Suppose we are merging these two, population with GDP. This population, this data frame with this data frame GDP. Okay, how does it go? How does it happen? Let's check. Now same, check this. See, before we once let me display the result. 1 second. I'll make you easy. I'll make your job easy first. Let me. Okay. So first, run this population and then run this GDP. Okay. See this data frame. I'm merging with this data frame using the country as common column. So here four rows are there. Here three rows are there. India is there in population, but it's not there in GDP. So what it does is it eliminates this whatever is not present. It by default it eliminates that row. Okay. By default it eliminates that row. This is known as this. It is default. You don't need to mention anything. It is default inner join where the column it retains rows present in both sides. So whatever rows that are present in both sides, only that rows are retained. Other rows are not retained. That you should make note. Both sides. What are both sides rows? US, China, Japan, US, China, Japan. India is not present. That is not retained. Okay. So we did not mention any inner join here, it takes by default. Suppose let's define an outer join here. Outer join. So we are explicitly mentioning the outer join here. So how we have kind of constraint called how and defining outer. Okay. So what does outer join do? See the result and tell me. It is retained. The India row is also retained, though it is not present in GDP. It retains, whether irrespective, it retains all rows and values irrespective of whether it is present or not. Present or not, it retains all values. Okay, remember. Now we have another operation called left join. Left left join. Here just replace with the left. And how does the left work? Just see the output and tell. See here left. What is left here? World population, and right is world GDP. Remember, this is left to our hand, right? This is left is population and right is GDP. So the rows here, the interpretation is that retains all rows present in left. Here left is population data frame, right? Since India is present in population, it is retained. Since India is present in population data frame DF, it is retained. Okay, then we have another join called right. Here you have to give right. Right, same interpretation, but it just run this and see how it runs. See here India is not written. Why? Because all right join means retains all rows present in right. See, it retains US, China, Japan. What are present in GDP? US, China, Japan. All those will be retained. Here, right is GDP, GDP data frame. Since India is not present in GDP data frame, it is not retained. So very important. So please make note of it. So just to give a recap of this merge, we have, suppose if we do merge, you have to give on function. What are the data frames? You have to give two data frames, and on. What on is common column. So once you give this by default it is inner join, retains all rows present in both sets, common rows present in both sets. Outer join is retains all rows and values whether present or not. See, it retains every row present in both the data frames. So yeah, here you have to mention how is equal to outer. Left join is retains all rows present in left data frame. Right join is retains all rows present in right join. So this is what so very important, please work on this group by very important group by, and also merge very important manipulations in the pandas. Group by and merge are very important, so work on this. Let's continue the other concepts in the next video.